Good morning, everyone, and welcome to this webinar today, hosted by the Connected Places Catapult, which is all about how drones can help us understand the UK's changing coastline. So my name's David Pounder. I'm a systems engineer working at the Catapult across our air mobility projects, which includes the Pathfinder Catalyst programme, which this webinar forms a part of. So I'm not going to go into loads of detail about the programme itself today, since we've got a load of really exciting stuff to cover. But in a nutshell, it's a programme we've been running since early last year, funded by the DFT, and it's all about accelerating drone adoption in the UK and therefore the benefits that come with that. So we've been working across multiple sectors, including housing, agriculture, rail, search and rescue, and today we're looking at coastal monitoring as a really great example of an environmental use case. So before we begin, just a bit of housekeeping. So a reminder that this session is being recorded, so you can watch it back later or share it with colleagues, and the PDF slides will be available separately too. It'll all be available on the Connected Places website after the event, and we'll also send a link round to all attendees. And if you follow us on socials, you'll see it there as well. I'd also just mention that although the invite says we'll finish at 11, we may stay on slightly after that if we get more engagement and questions. But the main content will be within the hour for sure. So next slide, please. Great, so we've got some really great content lined up. So after I'm done talking, we'll hear from the Environment Agency, who will be setting the scene about coastal monitoring generally and kind of where drones fit into the bigger picture. Then we'll hear from Survey AR, who carried out the surveys, and they'll be taking a look at the process itself and the outputs that we get from it. And then we'll jump back to the Environment Agency to kind of summarise and lead us into the Q&A. So speaking of Q&A, please do get engaged. You can ask questions at any time using the Q&A function at the bottom, which is separate to the chat. You'll see them next to each other. We'll only have one Q&A session at the end, so ask them when they're relevant, and we'll save them up and we'll answer them at the end together. If you want to have separate conversations in the chat or just introduce yourself, leave your contact details into the chat, please feel free as well. Okay, so that's quite enough from me. I'm going to, as a teaser for the rest of the webinar, just play a couple of minute video about the work we've done, and then I'll hand over to Lucy and David to take us from there. Next slide, please. Connected Places Catapult are the UK's innovation accelerator for cities, transport and places. As part of the DFT-funded Drone Pathfinder Catalyst programme, we're showcasing the growing potential for drone operations across UK industries. Today, we're working with the Environment Agency's Anglian Coastal Monitoring Programme and Survey AR to see how drones can be used to monitor the UK's changing coastline.
Survey AR enables clients to make data-led decisions by providing environmental surveys and land condition surveys using the latest drone technology, sensors, underpinned by rigorous scientific analysis. Traditional ground-based surveying methods require a person to be at the point of surveying. So that could be a risky point at the top of an unstable cliff or at the bottom of an unstable cliff or in an area of coastline that could be cut off by the tide. The second aspect is that the data is often quite sparse.
The Anglian Coastal Monitoring Programme collects topographic and bathymetric data and aerial photography for our partner organisations between the Humber and Thames estuaries to support them with their coastal management decision making. The high-level aims of coastal monitoring are to establish a long-term data set from which to derive statistics such as the maximum and average rates of change. This helps managers determine the condition of their beaches in the context of the historical dataset.
Using rotary wing drones, we can access all kinds of areas relatively easily, cover about 1 kilometre of coastline, and with high-resolution colour cameras, multispectral cameras to look at vegetation and thermal cameras, we can really offer great insights into the environment.
The data captured today and previously by the drone has been before and after a particular event, Storm Arwen, so we can quantify beach lowering and cliff recession using the two surveys.
So drones, for me, actually have really changed the face of what we can do in a lot of science areas. And for coastal monitoring, that allows us to use a variety of different cameras and sensors that are relatively low cost compared to other methods, and make these measurements routinely and repeatedly to gather a rich data set. For coastal surveying, the next steps, I think, are to increase the range of drones that they can fly in a single flight. That is essentially moving towards beyond visual line of sight. The second aspect is something we're working on, which is delivering the data to the client in a very usable format, where the user can visualize the data very easily as if they were there.
The UK is on a journey towards unlocking the benefits of the data that drones can provide. To find out more about how drones can support your organisation, please get in touch. Brilliant. So now I'll introduce Lucy and David. Please go ahead. Sorry, Lucy, are you on mute? I can't quite hear you. Let's just try and sort this out. Apologies, guys. We'll fix this in a mo. Lucy, Leanne suggested maybe changing headset, or you've still got a mute icon next to your name.
How about now? Is that any good?
Perfect.
Okay.
All right, go ahead.
Different USB socket. Right, good morning from the Anglian Coastal Monitoring Programme. Sorry about that. Thanks to Catapult for inviting us to be the use case partners for this project and explore how drones could be used in coastal monitoring. My name's Lucy, and I'm going to introduce you a bit more to the programme. If you saw a bit in the video, talk about why we monitor and how we currently monitor and what we do with that data. So then I'll pass to David, our data analyst, who will describe some of the benefits that we've seen from this project of drone data, how it can add to our program and help us try and meet the needs of our reporting objectives more efficiently. So the Anglian Coastal Monitoring Programme is one of 6 in England's national network of regional coastal monitoring programmes. We collect data, as I said, between the Humber and Thames estuaries, so that incorporates the Lincolnshire, Norfolk, Suffolk and Essex coasts. And the programme was the first, the Anglian one of its kind, and started in 1987. And some of our topographic data has now got a 30-year data set since 1991. We've been collecting some of our beach profile data, so that gives us a really robust data set to look at shorter term changes and variability of things that climate change has perhaps induced. So the data is all available under the Open Government License at coastalmonitoring.org, and it is commonly used by flood and coastal erosion risk managers and stakeholders and planners, as well as students and academics. So let's go on to the next slide, talk a bit more about the need to monitor. So as I said, it's really driven by our partners, and they are the coastal groups of England, and they're comprised of the lead local flood authorities and coastal protection authorities that have the duty to protect the land in their district under the Coastal Protection Act. But more and more, this means actually putting adaptation plans in place and working with nature, opposed to like traditional hard engineering schemes. So in the top left, you can see how variable some of our beaches are. And in the bottom left, you can see the Linkshore Renourishment Scheme, which some of our data informs the volumes of sediment needed for renourishment. And on the right, you can see some of the impacts of coastal erosion of the characteristically soft cliffs of East Anglia, attributable to the base rocks, which are molded by these quaternary glaciations, but the impacts of sea level rise and perhaps increased storminess are really taking their toll on rates of change. So it's important that we monitor these rates to inform managers and review shoreline management plans. Quite commonly is a use of the data, and really provides the need to monitor and provide a robust sort of empirical evidence. So let's look at how we monitor. So the topographic surveys that we do, as I said, some have now a 30-year history. They're done on foot with a surveyor with a pole and a GPS, and they provide us with a very accurate point on the Earth's surface, and the precision is 1.5 centimeters. We can use these winter and summer surveys to build up a picture of change in a key contour, like the mean high water or mean low water level. And as you're seeing on the right there, we can plot these changes over time and see what the general trends are of our beaches.
Leanne, could you just go on to the next slide, please? Thanks. We were just on the wrong slide, Lucy. There you go.
Sorry, there we go. So that's the graph that I was just describing there, which maps some of the contours. The changing on the bottom axis is the change over time. So yeah, that's good, trustworthy data that we put into our trends reports that we produce once a phase for the different counties on our coast. Let's go to the next slide, which will be the hydrographic data that we collect on behalf of our partners from the EA survey vessel there that you see. This gives us, this is what's multi-beam bathymetry data collected with an echo sounder. It's got 0.5 meter resolution, and the uses are really for, again, looking at change over time if you've got multiple survey data. Also, commonly our partners need to plan routes inshore between the very shifting sandbars and marine geomorphology there that allows access for barges to deliver sand or rock to coastal frontages that are undergoing large capital schemes. We also build sediment texture maps. So you're seeing one there of the Lincolnshire coast, and that's made from the bathy data and grab samples as well. Right, let's go on to the next slide, which is one of our two of the aerial surveys. So these are manned, unlike the drone surveys, and with a camera strapped to the hull of the plane. These are done between May and September to provide a greater number of cloud-free days and capture vegetation in full bloom, always coincident with spring low water, to get the maximum extent of the beach or mudflat or area of coast that we're looking at. And the data derived is auto-rectified, so we can relate it to real-world coordinates, and it comes at 20 meter resolution. So that's the image you're seeing there on the left. And with this aerial photography, we can build habitat maps, like the example you're seeing on the right there. And with the change in these sort of high-level habitat maps over time, we've got an example there from Essex where there was a breach, and we can see what the changes in habitat are for the biodiversity action plan.
Okay, the last type of survey that I want to talk about, or we are exploring other innovative methods, but this one is of most relevance to the case study. It's the LiDAR data that we also get from the EA's planes, and it's flown in spring or autumn, and it's for collected every phase, every other year, and or more often for priority areas, perhaps with large renourishment schemes. We want to capture change there more regularly. So with this data, we get spatially continuous data. So it allows us to see, build a whole surface model with 15 centimeter vertical accuracy. And this is commonly, we use the 1 meter resolution there. So you've got an image of how one area in Suffolk has progressed over time, over 5 surveys between 2003 and 2021. So you can see how the LiDAR data helps map these changes and look at elevation gain and loss. So we also put these in our trends reports, but deliver bits of analysis for our partners to look at specifically where they're gaining and losing sediment, and working out where it's going and where it needs to be replaced. Okay, I'm going to pass over to David now. He's going to talk more specifically about the benefits of the drone data that we've discovered.
Hi, so what are some of the benefits that we anticipate that drones might bring to our program and our partners? So there are some obvious technical advantages to using drones. The first of which is the higher resolution that's possible to capture. So looking at the image on the slide now is a comparison between the manned photography that Lucy was just speaking about, and that's on the left with a 20 centimeter resolution. And on the right is the same area captured in November from the drone survey, and that has a resolution of less than 2 centimeters. It's quite visually clear to see that it's easier to delineate coastal features such as the cliff top and toe in the drone imagery. Additionally, it's possible to zoom in further on the imagery. So if we could just move on the image, thank you. You can clearly see here there's a ground control point, is that little green area, and you can see footprints in the sand to show the scale of how far you can zoom in. These features would just not be possible to see in our aerial photography. If we move on to the next slide, please. The data acquired from drones is spatially continuous. So as an example of that, if we're looking at the image here, this is a comparison between our manned aerial LiDAR and our warped topographic profiles. Every dot in that image represents a height measurement taken. And you can see how there are lots of measurements in between the two transects. So any features or any changes in that area would be missed if you were only doing warped topographic transects. The drone technology is able to capture a point cloud density that is similar or even higher in some cases to the aerial image that you can see here. Additionally, the warped profiles only have a point at the top and at the toe of the cliff, and we know these to be inaccurate in some cases due to the health and safety risks of putting people on the top and at the bottom of a potentially unstable cliff, whereas the drone is able to capture measurements all the way down the cliff face. Finally, drones may offer more flexible deployment options than our manned aerial surveys for small and inaccessible areas. These technical benefits translate into added value for the ACM program and for our partners. As we've just seen, the high resolution imagery provided by the drone survey enables us to more clearly pick out cliff lines. This could improve our cliff recession analysis, which is becoming increasingly important as communities look to adapt to the challenges of climate change and rising sea levels. Having a spatially continuous data set enables us to create more accurate estimations of sediment volume than is possible simply just by interpolating between the topographic warped profiles. Our partners can then use this data to provide more efficiency in their nourishment and recycling schemes. The data also allows us to better understand and quantify the damage and recovery cycles associated with storm events, such as the Storm Arwen event that was captured by this case study. The flexibility of drones offers a number of different applications. We are able to plan repeat surveys within a year, which can be difficult with our manned aircraft due to the high level of prearranged use. This could reveal seasonal changes in the sediment budget, which would not show up with annual surveying. The short lead time for drone surveys mean that post-storm surveys are easier to conduct. The process of drone-based surveys is well suited to small and bespoke areas. These would be inefficient for the aircraft to survey, both in economic terms and the output of carbon. There are potential further carbon savings with less human resources required to travel to site, and it's possible we may see an environmental benefit from not disturbing the sensitive environments. However, at present, there is a caveat on this as some access is required to the site for the ground truthing process. Finally, drones may be able to replace some or all of our warp profiles over time, which could yield cost savings as the technology matures. I'll hand over to Survey AR now, who are going to discuss technical details of the project before we present some of our key findings for the case study. But for now, thanks for listening.
Rick, are you there?
Yeah.
Oh,
hello.
yeah, there you are. Hello.
Apologies for that. Hi, yes, many thanks for joining us. If we could just go to the next slide where I'll introduce myself. I'm Rick Thomas. I'm a technical director of Survey AR, and I have a PhD in atmospheric science. And for the past 10 years or more, I've been building systems to make cutting edge in situ data measurements, primarily from drones, including flying beyond line of visual sight for turbulence and cloud measurements. It's real clouds, not the data clouds. Volcanic plume detection and methane gas sampling. But together now with William Kirk and his 30 years plus experience in environmental consulting, we had a great team to tackle some of these pressing environmental challenges that we're facing today. In this talk, I'm going to focus on the work that we've been doing on coastal change monitoring and showing you how drone-based data can be a powerful tool in this essential work. We can go to the next slide. So just quickly for Survey AR, we really try and help customers easily gain the intelligence they need about the environmental capital they manage or monitor, for example, land, air, water bodies. And we do this by selecting the right tool for the situation. And that might be satellite, ground-based surveying, or by using drones coupled with advanced sensor technology. Our approach is rigorous, science-led, and aims to improve safety, cost, and time efficiencies for our clients through targeted data capture and analysis. Next slide, please. For this case study, the objectives are really to examine the ways in which drone-based data can support coastal change monitoring. And that includes measuring spatial and temporal changes, assessing the accuracy and efficiency, and describing the strengths and weaknesses of different techniques and sensors and how they're applicable for different situations and budget, whilst maintaining valid data to suit the need, which is primarily ensuring that this continuous data set remains trustworthy over time. Specific data requirements for this study included generating high resolution topographic data from the cliff area to mean low water springs, ensuring at least 50 centimeters resolution of the data, which we do much more than. Ground truthing of the data and the accuracy, and outputs in a format which tie into existing methodology for analysis. And I think this is often key. But we will talk about that in a second. So next slide, please. I'm going to be brief on the technology in the interest of time, but I'm happy to take questions later. But in short, we used 20 megapixel and 60 megapixel red, green and blue cameras, a multispectral camera and LiDAR. platforms ranged from sub 250 gram camera drones to our sub 25 kilogram custom build drone. We generally use automated flight plans, which are controlled through commercial software. Part of the requirements was to use ground control points, and these were laid out carefully in planned locations and surveyed into less than 10 millimeters accuracy. Flight management and safety is paramount, and we have the necessary authorizations from the Civil Aviation Authority, appropriate insurance, and we also contacted landowners to ensure their knowledge and permissions were required. We manage people on the ground in public areas through assistance, and we work to checklists to make sure that not only we maintain safety, but also that the instruments and data is collected robustly. Flight operational methodology for some coastline work that I did a few years ago was written up in a journal by a PhD student, and I'm happy to send that to anybody who's interested. Next slide, please. So for this survey, the target area was split into two key survey zones, essentially an area of erosion and an area of deposition. The key constraints in any of this type of survey is the weather and the tides. And of course, in January, December and November, this can be quite challenging to combine. But the dates really coincided with the lowest tide possible, as that was the key driver of this. In addition, of course, camera imagery and multispectral imagery is best captured during certain light conditions. And for multispectral, that's plus or minus 2 hours of solar noon. And with the sun being low in wintertime, that's not always ideal either. The key is really to be ready to safely fly at the right moment with the operational logistics in place. And in November, I collected some initial data during a reconnaissance visit with this very small drone, which then gained in importance really due to it just being prior to the storm Arun, which arrived on the coastline on the 26th of November last year. We trialed the color cameras, multispectral and LiDAR systems. Primarily, we use photogrammetric methods, which are well suited to this type of terrain and needs. The survey areas themselves were quite accessible and relatively quick to survey, really less than half a day, including the ground control point layout. Flight times only were on the orders of 1 to 2 hours per section, and less really for the high resolution camera, which can cover large areas in more detail from a higher altitude. And obviously this altitude is quite key to the surface resolution that you can get out of any data survey. Surveys do produce a lot of data. We're used to this, as are the Environment Agency, but we are also aware of how best to manage and distribute it by a variety of methods. So once we have the data, which we captured, then we process it. So we can go to the next slide. For photogrammetry, the data comes in a series of overlapping photographs. Or for LiDAR data, it's points and flight trajectory data. And these are processed to form a dense point cloud reference to a coordinate system, so we can geo-reference it on the ground. And these geo-reference point clouds are then made into textured 3D models, which you can see in the video here. Multispectral imagery is also calibrated and against reference panels, which account for the light and light sensors. And ground control points are used to check and reference the model. So the resulting data at this stage certainly shows the ability of drone methods to create rich models from which data products can be derived. But the key, of course, is the accuracy, and particularly that accuracy is suitable for the use case and allows repeated surveys to be compared. Next slide, please. Okay, it's the only one with lots and lots of numbers in it, I think. But the accuracy assessment essentially compares the georeference point clouds with ground control points. And here for part of the deposition section, key metrics of horizontal and vertical precision show 6 and 5 centimeters respectively. This is absolutely within the needs of the use case to monitor coastal change. Next slide, please. Once the data is processed and assessed, then we can generate the high resolution outputs for for more detailed analysis to tie in with those workflow streams. And here we have a digital elevation model on the left, which is colored by height, and it has a 3.3 centimeter per pixel resolution. And an orthomosaic image on the right, essentially the images stitched together and accounting for the topography, which has a resolution of 1.7 centimeters per pixel. So really, really high resolution imagery data, which can then be imported into geographical information packages and compared directly with other layers. So for example, the white lines are the Ordnance Survey master map data layer, which show excellent alignment with the key features. So now we can use the data to look at the other Environment Agency data described earlier and see how this can be used to gain insights into the effects of coastal change in this region. Next slide, please. I often get told my slides are a bit too busy, and it's probably as busy as it's going to get here. But so in the top left is, let's start there, is a top-down image of a section of cliff erosion showing the progression of the cliff top line from 3 survey dates of November, which is orange and on the right, December, which is red and in the middle, and in the January survey, which is blue and on the left. We can immediately see how the cliff has moved back in a short time at this location. It's quite dramatic, and we can see that there's hard standing there from caravans which had to be removed. Now the white line, which is perpendicular to those cliff top lines, is a cross-section line which is used to draw the profile slice on the right. And in this figure, we can see the progression of erosion between the surveys also, but for the whole cliff looking sideways through it. And we can see a 2.1 meter loss of the cliff top over the time of Storm Arwen, and 3.6 meters in the 57 days over December and January. The EA LiDAR points for the same slice are shown in green, so we can see how our point density is much higher than those obtained through the crewed aircraft. Now on the bottom right there, we can apply these white lines, these cross sections, to any point through the model, through the point cloud or the model, and generate a cross section at any point. And in the bottom right, we do this at one of the transect survey locations, and you can see how we really get rich data of the cliff face, which improves the analysis that one can do of this type of data and provides really great intelligence on the site. And further, what we can do is, for example, here on the bottom left, I've subtracted the digital elevation models between time points to show the areas of loss and sediment movement, with the red areas showing loss and the grey gain. It's possible to see the line in red where the cliff has been removed at the 2 time points, but also where it's slumped at 2 sections in the middle between November and December, and then the resulting sediment was then removed by the time of the January survey, and they look like the two red dashes. We can also do volumetric calculations and work out the actual amounts of material removed at different sections, and use the data in a variety of different ways. Frankly, I could talk for hours about it. But in order to keep this brief and fairly light, I think just this slide gives a picture of how the drone data can capture the change dynamics occurring between those manual transect surveys, which are shown in purple, at a temporal resolution not really readily available due to cost and resolution of the crewed aircraft LiDAR. Next slide, please. But of course, it's not all about erosion. Of course, these 2 images show how the deposition section has changed between the 2 surveys, with the growth and infill of the seaward portion easily picked up on these aerial images. And again, we have the point cloud data to quantify this in more detail. And picking up this type of change through manual surveys is not really practical, and we can see where the transect lines extend to in these regions. Next slide, please. I'm a big fan of multispectral data and all kinds of other wavelength analysis. Here I'm showing a called a CIR composite image, which really helps bring out certain features of the landscape. So for example, we've got the bright red areas showing healthy vegetation, black corresponds to water, and grey and green colours are siltier sediment, and white shows sandier sediment. We can do further analysis on this to semi-automatically classify these different regions into a particular habitat and feature types. Next slide, please. We are real strong believers in public engagement and giving people the tools they need to access the data. So we've developed ways to utilize computer games engine technology to deliver all kinds of data in accessible format on a variety of platforms. And where really games engine optimization of models can reduce the computational burdens, and they offer easy to navigate interfaces, reducing the need for training in bespoke software packages and allowing a lot of people to access complex data. And overlays can be added in to show, for example, the difference between multiple surveys. We think this can really help engage communities too in this type of work where it's been done in an area. Next slide, please. So crude, just to compare the different methods really. Crude aircraft LiDAR offers a reasonable coverage, really quite good at less than 1 meter surface resolution with good accuracy at less than 15 centimeters. It's not as regular as may be ideal due to its costs, and it can miss some of the important finer details. Very good for kind of, baseline robust data. Manual ground-based surveying is regular. It's very accurate, not very good coverage essentially between the survey lines, which may be about 200 meters apart, and also, as mentioned, it doesn't capture the cliff surfaces very well, which may be too dangerous to survey. Drones have excellent data coverage and are easily deployable, but not suitable for all weathers or locations. And whilst ground control points are required, access is also needed to the areas under the survey. Photogrammetry, I think, is a very useful go-to tool for drones, provided it's done correctly. It's relatively easy, lower cost, and is often comparable with the accuracy of LiDAR. Well, LiDAR systems, though more costly, are really best used for situations with lots of vegetation, which it can penetrate to get the true ground height, or buildings as well, which come out a lot cleaner and with LiDAR data. Multispectral photogrammetry allows really great insights, but is compromised by rapidly changing or poor light conditions. So in essence, one has to pick the moment carefully, and as I said earlier, be ready to fly in the right conditions. Next slide, please. So some quick lessons really from this case study is that rapidly changing conditions require a quick response method for a large area survey, and drones can offer that in a rapidly deployable method. Survey of public areas does require careful planning and management. The method and approach is critical in achieving accurate and precise data, and really this is key in order to ensure that this long-term continuous data set is robust, and we don't have and the data ties in well with those existing data sets. For accuracy requirements, I think there's often little net gain in using LiDAR over imaging, particularly given the cost factors and also some of the management issues in flying these larger drones. And for repeat surveys, of course, a workflow for comparison, analysis, and stakeholder engagement is essential, just in order to make everything run smoothly every time. Next slide, please. So in terms of the future, the whole area of drone-based work and surveying is rapidly changing, and there's enormous scope for its use and development in order to fit a variety of use cases. Methodology improvements can include cloud processing, for example, which we can do, but we really needs a very good mobile internet for this to deal with those large volumes of data rapidly and in the field. Of course, one can process data in the field directly. There are ways to remove the need for ground control points, for example, real-time kinematics, which is a way of gaining more accurate drone data. This can suffer from satellite dropouts and so on. And I think for rigorous data validity, it's best to use ground control points where possible in the short term. One could also consider using a fixed wing aircraft for longer linear coastal areas. Largely, this is about the methodology for deployment of this and the sensor integration, flight speed and coverage needs. Often it's simpler just to hop sections with a rotary wing device. And for a fuller picture, really coastal change, I know some of this work is been done, but further work on the bathymetry changes in measurement, I think would be very useful. And there are a number of drone-based solutions which can also help with this niche. In the longer term, what we call extended visual line of sight and beyond visual line of sight are great options if the sensors are well integrated and can be rapidly deployable to hit the right weather, tide and light windows. And of course, the administrative burden and equipment costs of these systems can be managed. Automation as well is possible for areas of where rapidly repeatable surveys are required, and this can take the form of essentially drone in a box solutions, which may be entirely autonomous in the future, in the longer term. Smaller low-cost LiDAR sensors are also hitting the market and can make this kind of data more accessible and affordable, but the data validity really needs rigorous testing. And of course, finally, the advent of higher resolution satellite data to support the change assessment is also a useful tool, but it's unlikely to compete with many of the advantages that can be brought by high density data, including measuring these vertical surfaces and overhangs. So I hope that's given an overview of this case study. And if we have the next slide, I would just like to say thank you very much for your attention, and to our team and partners, the Environment Agency and the Connected Places Catapult. Please visit us at the Drone Pathfinder Showcase event on the 14th of March in the Milton Keynes Stadium. You can join either in person or online. And we'll be talking more about this and also about our swarm drone project for air quality and meteorological measurements. Thank you very much.
Thanks, Rick. I think we're going to go over to the Environment Agency again now, just to kind of summarise from their point of view.
Hello. Hopefully I'm back. I can't see my own picture, but
you are back.
Excellent. If we could just move on to the next slide, please. So yeah, we've already learned quite a lot from this process in quite a short time, and I believe we'll continue to learn a lot more as we spend more time with the data. But we'll share some of our first findings. We're able to see the outputs from the survey very quickly after the capture date. Typically with our routine aerial LiDAR, for example, we'd expect to wait several weeks to receive the processed data. The rapid turnaround from drones means that we are able to present partners with the data much sooner. And this could potentially help them shape temporary measures in response to storm damage, for example. The data we receive from the drone surveys has a sort of two-in-one benefit, as we're able to produce an elevation layer as well as high resolution photography, which is captured on the same day. This is not the case with the manned flights, where typically our photography is captured in the summer and LiDAR in the winter. Having the two data sets from the same time period overlaying on top of each other makes it a lot easier to interpret the data. The photography provides context to the elevation data, and this can help inform hypotheses and provide reasons for the observed change in the elevation layers. We found that drone surveys can be very quick and easy to perform. However, this process is quite involved and requires careful planning in order to collect survey grade data, which can actually be used for analysis. For this survey, we were able to acquire permissions from the relevant parties and an assent from Natural England to fly in the area. Being more aware of which permissions are required to carry out this type of survey has been a useful lesson to us, and we're now working to gain assent from Natural England to fly over the entire Anglian region. Some areas may require site-specific assessments, for example, when flying over a designated area, for example, bird nesting areas. Ground control points were needed in this survey as the current RTK technology is unable to achieve the survey grade and accuracy that we require. This means that access was required to the majority of the site and increases the potential cost for the survey in general. As a result of the case study and the conversations with Survey AR, we have a much better idea of when and where drones are most useful, as well as their limitations. It's important to think of drones as an additional tool rather than the answer to every problem. We see drones being of most use in areas with cliffs or narrow beaches, mostly for the access requirements, as well as sort of technical limitations with vegetation and sort of the width of the beach. The data captured either side of Storm Arwen proved a useful demonstration of how drones can show very short-term change. Therefore, we think drones may also be ideal for repeat surveys as part of specific schemes or monitoring plans along small frontages. Next slide, please. So the key learnings from this case study have directed the next steps that we will take in ACM, as well as the ideas that we've had for potential future developments and applications of drone surveying. With our learning from this project and the advice that we've received from Survey AR, we are now developing a specification to include drone surveying as part of our routine surveying going forward. As previously mentioned, we've found that ground control points were needed to ensure the accuracy. However, as the technology matures, it may be possible that RTK will take over from this and we wouldn't need ground control points. This would enable us to survey larger areas and potentially bring more benefits in terms of surveying areas that are inaccessible to walk to get onto the actual beach from. Although multispectral imagery was not the focus of this particular project, Survey AR did provide some imagery using the red edge and in near infrared bands. This shows up the vegetation quite well, as you can see in the image to the right, where sort of the red areas are the vegetation and the sort of tan areas are various levels of moisture in sand, and the black is water. These could potentially be useful in creating enhanced habitat maps, which could be of use to some of our partners who are more interested in biodiversity and sort of Natural England or wildlife-based agencies. In the future, we might be interested in using more spectral bands, so more multispectral or maybe even hyperspectral data sets. Alternative survey methods could also be used as part of the drone survey. So one idea we've had would be to use LiDAR drones at night, which could create less disruption to local residents and reduce the impact of uncontrolled people on the survey team. Once we have more time with the data, I expect more analysis options will become apparent. We're particularly interested in developing our 3D change analysis of cliffs to monitor cliff recession and stability. So we're sort of, there's a general trend in our analysis where we're moving from sort of analysis of 2D planes to a more 3D and sort of holistic analysis of the coastal environment. And I believe that drones can play a big part in this. So that's all from me, and I think we're just moving on to questions now. Thank you very much.
Brilliant. Thanks, David, and to everyone who's presented today. Yeah, we are going to move on to questions. I'm just going to really quickly, before we do questions, I'll just hop to the next slide, Leanne, and just in case anybody needs to leave before before we end the question session, because like I said, we might run over. I just wanted to pick up some of the points here, and then we'll jump straight to questions. So if you'd like to get in touch with anyone after this presentation, and I would encourage you to do so if you're interested in finding out more or doing it yourself, there are some emails there. And of course, these links will be in the slide pack that we send around to you. And I'd also just like to kind of point out that we do run similar sessions across other industries. So check out either recordings that we've done before. So they're on our kind of YouTube, and you can see the links on our LinkedIn and Twitter if you follow those. And keep an eye out for other things that you might be interested in. One particular thing I'll just pick out is the Drone Pathfinder Catalyst Showcase event, and that's on the 14th of March, and that's kind of a culmination of all of the work that the Pathfinder's done over the last year. We'll be inviting lots of people like Survey AR along to kind of show their technologies and what we've got out of it, and kind of the equivalents from the other industries. So that's being held in Milton Keynes on the 14th of March, starting at 10 a.m. So do look out for that. You can find more details on our website, or get in touch if you can't find those. Right, so I will now take us to the Q&A. So if everyone can get their cameras back on, and like I said, we're happy to kind of run over a little bit on this. So do keep more questions if some of these inspire you to ask another question or kind of go into more detail. But I'm just going to run through from the top really. Some of these might have been answered because they were asked earlier in the presentation, but we'll kind of cover them off quickly just for completeness really. Okay, so from the top then. Just one from Daniel Ronan, so this is in the chat, about using satellite images instead of manned aviation. What's the view on that? Is there a reason that we don't use satellite, or maybe we do for different uses?
So we do use some satellite imagery. The primary reason we don't is that both the drone surveying and the manned aerial flights are undertaken at mean low water springs, which enables us to see the biggest extent of the beachfront or the mudflat or whatever. With satellites, you tend to get what you're given in terms of the whenever the orbit passes over the area of interest. There is a scope to task a satellite to a specific time in some cases, but that's prohibitively expensive to do on a routine basis. So yeah, it's generally cost of getting the imagery exactly when we want it.
I would also say that the satellite imagery, and there are projects to make that more accessible for coastal monitoring purposes, but the benefits of the drones are really in the resolution of the data that we're getting as well, and there's coastal monitoring and in its inspection perhaps of assets that satellite imagery is looking into, and for that you do need the greater resolution, which may come in time with satellite imagery, but at the moment it's the lower altitude flights are giving us the resolution that we really need and is useful to us.
Just to add there, I actually gave a presentation for a workshop on the benefits of potential benefits of satellite imagery for coastal monitoring. If you kind of Google the Coastal Erosion from Space project by European Space Agency and British Geological Society project, I kind of gave a presentation on that, and it's all available online. But as kind of David and Lucy have said, there's a few barriers to operationalizing satellite imagery in terms of coastal monitoring, in terms of the resolution, kind of knowledge gaps, and kind of the skills that you and the expertise that you need in order to kind of make that into a product that you could use every day in the coastal monitoring program.
Brilliant, thanks guys. I think that's covered that. So on to the next one. There's a question from Kim Smith about whether we're flying kind of pre-programmed routes for identical coverage, or whether we kind of do it free form every time.
Yes, in general, we would use pre-programmed routes, absolutely. and that would allow us to fly the same altitude and path. There might be operational reasons why we change it a little bit, but ultimately we try and maximize the resolution on the ground and automate as much as possible.
Brilliant. And there's a few questions that have touched on the next one, which is about, and we've touched on this in the presentation as well, but I suppose just to wrap it up, the altitude, the kind of resolution that we get from drones. What are the factors that kind of impact that versus some of the other methods? So obviously we've talked about altitude and sensor resolution and things. So maybe just touch on that to cover some of these questions off.
It is largely, you can use, it's largely between the sensor resolution and the proximity. So you can use lighter instruments which might not be quite, well, might not be as good as the type of instruments that you use on the aircraft, but you're using them a lot closer, so you can get a higher point density essentially. Yeah, I think does that answer that question enough?
Yeah, I think so. And I think you went into more detail in the presentation as well after that question was asked. So I think we've covered that one. Now this one's maybe harder to answer, but you might want to have a quick go at it. But it's talking about the costs of drone surveys. So things like the cost of hiring them per days, per distance. How are those things worked out? It might be difficult to give actual costs on this, but
this is where I can defer to our commercial director, Will, quite easily.
Go for it, Will.
It's difficult because it depends on the circumstances. In this case study, we were running a number of different platforms and a number of different sensors, and we were running the surveys across really quite challenging conditions. So, for example, for one day, we anticipated that the survey would just simply take one day, but we'd planned for 2 days, and the survey ended up being across 4 days because of the weather kind of systems that were coming over. So in some cases for winter, we need to plan for longer campaigns for getting the survey data in. And that's why kind of in one of the cases at the very outset, Rick went out to the site to undertake a reconnaissance exercise. And the reconnaissance exercise gives us a benchmark or a test to kind of determine exactly what the conditions are and what we need to consider as part of our campaign for the survey. So I guess there is no easy answer to that.
No, maybe that is the answer. There's no easy answer.
Yeah.
But I suppose I would encourage anyone who's interested in genuinely finding out for their own purposes can definitely get in touch with Survey AR.
Yeah.
Brilliant. Thanks for that answer. So the next question, would having high fidelity wind maps, i.e. to 1 meter resolution and 1 kilometer per hour, would that be useful for survey purposes, either for flying drones or for modeling movement of particles along the coast? Does anyone want to have a go at that?
I can just come in for the flying drones part, absolutely, particularly if it's high resolution vertical profiles of wind. I would find that extremely useful. Normally we measure wind at the surface and we can extrapolate to some extent and assume it's logarithmic with height. And any kind of weather information and nowcasting essentially is always very helpful for picking those weather windows.
For the use case of that, for Aeolian sediment transport modeling, that would also be really good input data. So you need to be ground truth it as well. But yeah, to look at sediment budgeting and work out, especially for some of our schemes where the losses and gains and those due to marine, but also Aeolian processes, that would be useful information.
So that question was asked by Chris Daniels. So I don't know if that's because Chris Daniels has got that data, or is it just a general question? But do get in touch afterwards, guys. Yeah. Next one from Oleg Velka. Apologies if I've pronounced that incorrectly. So, hi, I'm working on a novel nature-inspired method of coastal defence. How can I get some cross-sections in different points across the Holderness coast, and how much would that cost? Sediment texture would be useful as well. I'm mainly interested in the cross-sections of the intertidal and subtidal zones. So I suppose you might not be able to go into detail there, but guys, if you want to offer to follow up.
I can jump in there.
Yeah, go for it.
So the Holderness Coast is part of the East Riding of Yorkshire Coastal Monitoring Programme. So there's a huge wealth of data that's collected by that programme in a similar way to the Anglian Coastal Monitoring Programme, which is freely available via the coastalmonitoring.org website. So I would encourage you at first point of call to explore that website and see what data is freely available before going any further into kind of commissioning your own surveys, because there is a significant amount of data that was collected. LiDAR, aerial photography, walked profiles, and bathymetry that's all collected there. So yeah, have an explore on that website.
Yes, I think that makes absolute sense. Pre-existing data, if it suits the purposes, should be the first point of call. And then, of course, we're ready if you want any more detailed information collecting. So yeah, just be in touch.
The sediment texture maps were done with grab sampling, so that is direct sampling, but there may be a place for drones and remote sampling, and especially with maybe the multispectral imagery to look at, as you would with vegetation, more species level. There may be room to look at more substrate level analysis in future with drones.
Brilliant, thanks for that. The next one, I think we kind of covered it in the presentation, but maybe just to reiterate. So is the drone-based methodology used in this case study replicated in other UK coastal areas?
I don't know that it's replicated in other areas as part of a routine basis. I believe drones have been trialed potentially, but not necessarily using photogrammetry in other areas. It's something that all of the coastal monitoring regions are interested in, and I think we're sort of the first to try it, really.
Just to add to that, yeah, it's an emerging technology. The coastal monitoring programs, we have our standard kind of methods of data collection. We're always looking for ways of innovating, but yeah, it's definitely an emerging technology, and I actually lead the kind of drone working group within the National Network of Coastal Monitoring Programs to discuss uses and kind of best practice for drones in the coastal monitoring program.
Brilliant. So next question is maybe hard to answer without going back to the other slides, but it was about whether the method comparison between different methods should also kind of consider the area. So I suppose that's a consideration when thinking about using a plane or a drone. And then also, do you ever use vehicles, vehicle-based GPS?
Sorry, what was the first part of that question, David?
So I think it's a kind of general point, actually, maybe not so much a question, but just in the comparing between different methods, I think the point is that lower resolution methods like planes, capturing data from planes, do allow you to actually capture more area though. So there's obviously a trade-off. So I think that's a fair point. And then there's a kind of second part. Do you use vehicle-based GPS measurements? Not sure what that would be.
So all-terrain vehicles for capturing, for instance, on what you would on foot, but with a quad bike, basically. So a direct sampling, and that would give us, we could build, and we have in previous used that method for larger expanses to collect the good data with good accuracy over a larger area, and not just on transects, but making more of a grid. So it's definitely an option, and it's frequently used in all the regional monitoring programs. Yeah, there's still potential for greater resolution even than the all-terrain vehicles with the drone data, And then you've got the other advantage of the drone data, which is not disturbing the site. And many in Anglia are designated sites with lots of breeding birds and protective criteria. So we decide what the environment needs and what the best monitoring technique would be. So this is just, yeah, absolutely another string to the bow.
Brilliant, thanks guys. At this point, there are quite a lot of questions that maybe we've already answered, so I'm going to kind of pick and choose from now on, I think, rather than going through all of them, just because there's some overlap. So Kim Smith says, has there been a relative cost comparison between drones and manned alternatives? Would that be challenging to do, given that they're different, aren't they?
The costs can between our topographic surveys on foot and the drone surveys for the same area used in this case study has been fairly well compared and is not too indifferent. It's the extra work done on top of that for the processing, which the drone data requires, whereas the topographic data, the sort of basic XYZ text files that we get, we would analyze that ourselves. So yeah, there's probably an additional cost of getting the processing of the drone data done that we don't have on the topographic, but the actual collection, the price of sort of collecting it, the time and human resources involved is comparable, I would say.
Just to jump in there, yeah, it's quite difficult to compare the two products, or walked profiles versus kind of a drone photogrammetry survey, because they're a different product. They're offering a different data set at the end of the day. So it's quite difficult to say, well, this costs that and this costs that, because yeah, they're offering different kind of levels of information to the monitoring program. And equally for the kind of manned aircraft versus drones, as the kind of point was made by Uwe, you capture a significant area when you fly with the manned aircrafts versus the drones. So we wouldn't send up an aircraft to capture a 1 kilometre stretch of coastline because it's not cost effective. But so that's the kind of the difficulty there in comparing the two as well.
Brilliant, thank you. Question from Chris Collett. So a number of future developments have been mentioned, but in broad terms, what would the ideal characteristics of a drone to serve the needs of a coastal survey be? So it's a kind of, what do you want out of a drone when you're doing this stuff, Rick or Will?
Yeah, that's a really good question, because you could build a bespoke system that ties in what you need, and to some extent, yeah, I think it will. Ideally, we will look to move towards very accurate positioning systems that we can trust, never have dropouts, for example. I think in my mind, I'm sort of toying with is it rotary wing or is it going to look more fixed wing? And to some extent, that depends upon the ability to fly extended and beyond visual line of sight, and testing of such a system to see if we could fly, for example, 50 meters out and collect useful data for this type of use case. So I'm sorry I haven't got a very clear answer right there. It's probably again some kind of combination between the two, isn't it? I'm keen on rotary wing aircraft for this kind of measurement, because they're just so easy and deployable, and right now we can use them. But I think in the future I'd probably look towards more fixed wing, highly accurate positional drone, which can do large stretches in one go at low cost and land on a beach without getting sand in its rotors. These kind of things, and fly in high winds and all the rest of it. Did that vaguely answer the question? I think so.
Hopefully, yeah. And I think if there's any bespoke builds on the call, you've got a brief there.
I was going to say the value of the lighter drones was that you could
pop them up in the more marginal conditions and still capture good data with elevation, with the photogrammetry as well, with before and after the storm. So yeah, there's a value of having a quiver of drones, isn't there? I think.
Yes.
Yeah.
Different
Okay.
conditions.
Next couple of questions. Well, there's a couple of points here. So one point around a couple of people have mentioned the Southeast Coastal Monitoring Program use drones. So that's interesting. There might be some link ups there. And then there's another question about we maybe touched on this already about different data for different needs, but what spatial resolution do we need versus what we can get? So is there a tendency to kind of oversample because we can, or is there the real value in getting that high res data?
I think that's a really great question. Actually, it is very key to take what essentially. Ideally, you just take what you need and work with that. It is very tempting to just collect reams and reams of super high resolution data and make really pretty models. That high resolution data, for example, is super good for communicating the kind of measurements that we make in a way that's accessible. So producing those nice models and so on. But for scientific purposes, you can always downsample, I guess, is the first thing. I'm always keen. I would like to get more data than we need, and then we can subsample from that. But in the terms of the cost and benefits, we can fly, for example, at higher altitudes, cover a larger area in one day, and get lower resolution data. And so it's a balance to be made for each different type of survey. And the only other thing that I would just add is that in terms of getting those cliff faces and some of the overhangs and things, I think the high resolution really does add to that. But maybe the EA have got something you'd like to add to.
Yeah, I was just going to say, kind of from an operational perspective, there are definite benefits in having high resolution data in some circumstances. However, we have to consider in the back end, if we're getting high resolution surveys for every scheme or bit of strip over our whole coastline, it's a significant amount of data, and actually we need to be a bit more directive with what we're capturing to ensure that we don't just get overwhelmed with data and then not able to do anything with it.
Thanks, guys. Yeah, I think that kind of answers that one. So just a note from Chris Daniels. So the wind data question was regarding a UKRI future flight program, Flarebright. They've been running a trial at Cardiff Airport. So have a look at the website, and he's left his details there. I think he'll said he'll be in touch. So that's interesting. Okay, so the next one from James Arnott. So we've been delivering a number of LiDAR surveys for EA on river systems and flood mapping. Is there discussion being held with other areas of the EA on best practices and lessons learned on accuracies and data handling?
So essentially, yes, all of the EA's various teams that handle data do speak to each other, and sort of best practice is shared. It's not like a specific project or anything, as far as I'm aware, but yeah, we do communicate.
I can just jump in there. So I know Andy Richmond's on the call, who's the kind of the Environment Agency drone lead, and he is kind of running the kind of projects looking into drones and their use within the Environment Agency. So yes, and he sits within our wider team. So absolutely, the findings from this are being communicated to him and the people that are working on that kind of wider drone project in the Environment Agency, to ensure that we are joined up and any lessons learned are kind of communicated across everyone.
Brilliant, thank you. Next question, we've only got a couple left. So from Gavin, this one saying, can you use drone deploy 3D modeling data? And that's drone deploy with capital letters, so that's a specific thing, I guess. And is this resolution high enough for your data archive? Is anyone familiar enough to give that a go?
So I'm familiar with drone deploy, and it's an automatic sort of flight programming system to fly and collect drone data, and some of it can be automatically processed. I haven't used it enough to know what the output resolution and accuracy is, and to what extent you can assess that, you know, in terms of ground control points and so on. So I think that would need looking at.
Brilliant, thank you. And just kind of last few points. So Chris Collett, who asked the question about the ideal drone, has raised how about a drone with 0 carbon and 12 hours endurance and 600-kilometer range? So how about that, eh? So this, I suppose, talking about hydrogen-powered drones generally. Is that something that's on your radar, Rick?
Yes, I'd love to have something like that. Absolutely, why not? One thing to always bear in mind is, I don't know, did you say hydrogen power?
Yeah.
I know of some systems that have had hydrogen tanks on them, and that's interfered with the GPS, for example, and large chunks of metal near some of the electronics can cause issues. So if you can deal with all of those things as well, which I'm sure you can, that'll be absolutely brilliant. Yeah.
Great stuff. I think, unless I've missed anything, I think we've gone through all the questions. There might have been some overlap on some of them, but thank you very much for asking all those questions. And like I said, Leanne, if you just jump over to the next slide. Like I said, people's contact details are there. Please do follow up. If there's anything you want to link up, you want to do this kind of stuff yourself, or just find out more, you'd be more than welcome to get in touch with anyone who's presented today. Any closing thoughts from anyone, or shall I kind of wrap up there? I think. Brilliant. Well, it's been really great to hear from everyone today. Yeah, like I said, reach out to us if you want to learn any more, or you know, do get in touch. Please keep an eye out for the recording of today's session, and also on our social feeds if you don't already. So we've got LinkedIn and Twitter where we post kind of notifications about these kind of events, follow-up work. Like I mentioned, we have the showcase event on the 14th, which is going to be really exciting. So please do look into that if you're interested. The other thing I'll mention is over the next few weeks, we'll also be releasing a kind of related case study to this. We'll highlight some of the stuff that we've got in today's content, in today's webinar, sorry, and it'll also kind of outline some of the benefits of drone adoption for organizations thinking about similar use cases to this. So just to wrap up there, a really big thank you again to all our speakers today, for all of you for joining and asking lots of great questions. And hope to see you on another event in the future. So thanks again, everyone, and have a good day.